Hi, I'm Ms. Fung. Today we're going to look at kinematics. In the previous video we had a look at position, distance and displacement, and we also had a look at a little bit of on speed and velocity. So you might want to look at the other video to revise this first, because today we're going to build on that a little bit more. So velocity and speed. Firstly, we're going to look at velocity and we're going to look for the average velocity as well as the instantaneous velocity. Now the average velocity is when there's 2 points and you're looking at the average rate of change in position with respect to time. So x2 minus x1 over t2 minus t1. Whereas instantaneous velocity, so the velocity at that point, is the instantaneous rate of change in position with respect to time. In simpler words, dx dt. So we have had a look at this throughout the chapter, averages of rate of change and instantaneous rate of change. Today we're going to combine them with velocity, speed, so motion. Now with speed, we can have the speed or the average speed. So So the speed is the magnitude of velocity, so it's always a positive value. So whether the velocity is positive 3 or minus 3, the speed is just 3. Whereas the average speed is the distance over time. So let's have a look at... Batman, go away! Today we're going to look at velocity, speed and acceleration. When we look at velocity, we're going to look at two things, average and instantaneous. Remember that we've been going through the rate of change and we had a look at average rate of change and instantaneous rate of change. Do you remember the formulas for those two? Now the average rate of change with respect to time looks like that, x2 minus x1 over t2 minus t1. It is the average rate of change in position with respect to time. Whereas instantaneous velocity is the instantaneous rate of change in position with respect to time, or in other words, dx dt. So we've done lots of these in terms of average rate of change and instantaneous, but today we're going to combine them with motion. Then we're going to look at speed and average speed. Remember, speed we've seen before is just the magnitude of velocity. What does magnitude mean? It means you just take the value, you don't take the minus. So if the velocity was plus 3 or minus 3, the speed will still be 3. Whereas the average speed, we take the total distance and we divide it by the amount it took. We're also going to look at acceleration, the average acceleration and instantaneous acceleration. So the average acceleration is the average rate of change in velocity with respect to time, and that is v2 minus v1 over t2 minus t1. And instantaneous acceleration, well, it's the gradient at that point of velocity, or dv dt. But we know that v is equal to dx dt. So what happens is we can d dt dx dt, because v is dx dt, and we obtain dx squared over dt squared. So that's another way to look at it. Let's do some examples. A particle moves in a straight line so that its position x centimeters relative to the origin at time t seconds is given by x equals t squared minus 12t plus 11, where t is greater or equal to 0. Find its initial position, and then we're going to find a position when t equals 3. So the initial position means t equals 0. We often ask initial and final a lot, so make sure you remember what it means. So for x, time equals 0, what is x equal to? Well, 0 minus 0 plus 11 is just 11. So initially, it's 11 centimeters to the right. What happens when t equals 3? So we're going to sketch that first before we add more information. So at t equals 0, we are at 11 centimeters to the right. Now what happens when t equals 3? So we plug that in. T equals 3. And we can see that at t equals 3, x is equal to minus 16 centimeters. So we're going that way. So minus means to the left. And if we sketch the graph, it looks something like that. So at t equals 0, we start on a positive value of 11, and at t equals 3, we're at minus 16. So find its initial velocity. So we're traveling that way, right? So we start at t equals 0 at 11 to the right, and then at t equals 3, we're now at negative 16. What's the initial velocity? So we do the differentiation, and then we let time equal 0. So dx dt would be t squared becomes 2t, and then minus 12t becomes minus 12. So letting that equal to 0, we have, letting time equals to 0 because it's initial, we have 2 times 0 minus 12 is just minus 12. And the units, x is meters, x is centimeters, and t is in seconds, so it will be centimeters per second. And notice that we were traveling this way, so it makes sense that the velocity is negative. When the velocity is 0, what is the position at this time? So when v equals 0, what is x? So first we have to find what t is, and then plug t in to find what x is. So v is 0, so the equation for v is up here, 2t minus 12. We let that equal to 0, so we have 2t equals 12, dividing by 2, we have t equals 6 seconds. So the velocity is 0 at 6 seconds. What is the position? So at 6 seconds, to find the position, we put it into this equation there. So we're t is 6, and we can see that the position is negative 25 centimeters, or 25 centimeters to the left. Remember, you can't write minus 25 to the left because that's a double negative. So you can either write minus 25 centimeters from the origin or 25 centimeters to the left of the origin. Now, part E and part D. Part E, what is the average velocity for the first 3 seconds? So average velocity means x2 minus x1 over t2 minus t1. But our x2 is actually x at 3, x1 is initial, which is x0 over, so the final time minus initial time. Is this question very different to the next one? Let's just double check. Determine its average speed for the first 3 seconds. For this one, we'll have to look at the distance over time. So notice when it's velocity, we look at final minus initial location, position, whereas when it's speed, we look at the total distance. So these questions are here so that you can make sure that when you read the words, you use the right formula. So average velocity, so let's do that. x3 is over there, 16, x0 is at 11. Sorry, minus 16 because it's 16 to the left. Be very careful with that. We almost made a mistake. So we have the average velocity is minus 9 centimeters per second. Minus 16, minus 11 is minus 27, divided by 3 is minus 9. Whereas the distance, well, let's draw it out and try to understand it. In the first 3 seconds, we went from 11 to negative 16. So in other words, we have traveled from 11 and another 16. That's a total of 27 over the 3 seconds. So it is 9 centimeters per second. Now we notice that the final minus initial is minus 16 minus 11, which is minus 27. But we took the positive because speed cannot be negative. So be very careful that when we work out this section here, that the distance is never negative. Example 2. An object moves in a straight line, so its position x meters relative to the origin at time t seconds is given by x equals t cubed minus 6t squared plus 5, where t is greater or equal to 0. Find its initial position, velocity, and acceleration, and hence describe its motion. So we have x there. Initial means when time is 0. So x is equal to 0 minus 0 plus 5 is just 5. And velocity would mean we have to differentiate that. So t cubed becomes 3t squared, minus 6t squared becomes minus 12t, and the 5 disappears. And at time 0, velocity is equal to, well, when we plug t equals 0, we have velocity equals to 0. Acceleration is the differentiation of the velocity. So we have 3t squared becomes 6t, and then minus 12t just becomes minus 12. And when t is 0, we have minus 12. So we can describe this as initially the object is located 5 meters to the right of the origin, and it is at rest because the velocity is 0, and with an acceleration of minus 12 meters per second squared. Or you can say deceleration of 12 meters per second squared. Part B, find the times when it is instantaneously at rest and determine its position and acceleration at those times. So when is it instantaneously at rest? When is v equal to 0? Well, let's find what v equals 0 gives us. So when v equals 0, we have 3t squared minus 12t equals 0. Factorizing, we have t equals 3t minus 12. So t is equal to 0 or 12 over 3, which is 4. So at these times, what is it asking for? Position acceleration. So position at 0 would be 5. At 4, plug it in, would be minus 27. Acceleration from above, we can see a at 0 is minus 12, and a at 4 would give us 12. You can use a calculator to check these. So how do we describe this? The object is initially at rest 5 meters to the right of the origin with an deceleration of 12 meters per second squared, and then at 4 seconds it is 27 meters to the left because it's negative of the origin, and it's accelerating 12 meters per second squared. One more example, example 3. A particle moves in a straight line so that its position x centimeters relative to the origin at time seconds, where time is greater or equal to 0, is given by x equals 2t cubed minus 5t squared plus 4t minus 5. Part A, when is the velocity 0, or when is v 0, and what is the acceleration at this time? So first of all, find v by differentiating. So we have 2 times 3 is 6t squared, 5 and 2 becomes 10, and the 4t becomes 4, and then minus 5 disappears. So when is v equals 0? Well, let that equal to 0. Then we can take a common factor out of 2. We're left with 3t squared minus 5t plus 2. Factorize that, and we can see that t is equal to 2 over 3 or 1. Now, what is the acceleration at those times? Well, the acceleration is the the derivative of the velocity. So we differentiate that. 6 times 2 is 12t. Then minus 10, t becomes minus 10, and then 4 disappears. So at t equals these two things, what is a? So let's plug it in. We have a is equal to minus 2, or decelerating at 2, and at 1, a is equal to 2. So at t equals 0.667 seconds, acceleration is negative 2 centimeters per second squared, or you can say decelerating at 2 centimeters per second squared. And when t equals 1, we can see the acceleration is 2 centimeters per second squared. Part B, when is its acceleration 0, and what is its velocity at this time? So a equal to 0, so that equation there. So 12t equals 10, so t equals 10 over 12, or 5 over 6. What is v? So plug it into v. So 5 over 6, plug into v, we get minus 1 over 6. So we can say at a equals 0, velocity is minus 0.167 centimeters per second, or 1.167 centimeters per second to the left. So you either say negative or to the left. Thank you for watching, and you might want to try these questions again. I'll see you next time. Bye!